We are going over matrices. We've done matrices before, it's just been a while. A matrix is an arrangement of numbers or elements in a rectangular grid with brackets on either side. When we talk about the dimensions, we talk about them as rows by column. So this is a 3 by 4. Now, one thing we didn't talk about was elements themselves. Since we call this matrix A, we denote the elements as lowercase a. So we always talk about matrices in capital letters. The elements that compose that matrix, we talk about them in lower letters. And the numbers that follow, so 2, 1, row 2, column 1. Row 2, column 1 would be -1. That's it. So if we look at the first one here, A, and we want to say the dimensions of A, the dimensions would be 2 by 3. 2 rows, 3 columns. And if we want to find the value of element A 2, 1, so element A is in the second row, first column, which is, that's it. State the dimensions of matrix B. 3 rows, 2 columns, so it is a 3 by 2. Find the value of element B 3, 2. -1. Third row, second column is -1. The top left is element 1, 1, first row, first column. Questions on these here? If the matrix has exactly 1 row, we can call it a row matrix. If the matrix has exactly 1 column, we call it a column matrix. If the matrix has the same number of rows and columns, we call it a square matrix. And if all the elements in the matrix are 0, it's called a 0 matrix. But this is not the same as just a matrix with 1, 0. They're not the same. Even though they are both 0 matrices, they're not the same matrix. Adding and subtracting matrices. To be able to add or subtract 2 matrices, the dimensions have to be the same. A, in this case, is a 2 by Q. And we're going to add to it matrix B. Well, matrix B is also a 2 by 2, yes? Since they're both 2 by 2s, we can add them together. And when we add 2 matrices together, we add the corresponding elements. So we say 16 plus -4, 2 plus -1, -9 plus -3, and 8 plus -7. 16 plus -4 is? 2 plus -1 is? -9 plus -3. And 8 plus -7 is? That's it. Questions on these here? We ready for the next one? So B minus C. Why can we not subtract these two? They're not the same dimensions because B is a 2 by 2. C is a 2 by 1. Not possible. It's just not possible. No real solutions is really just implying that there are complex solutions, but here there's no way to do it at all. A plus B plus A, well, and then we add A to it again. Let's look at this here. 1A. So we have these two being subtracted. Well, the first one is a 2 by 2. The second one is also A. So we can subtract the 2 from here. Now, we can also do this in the calculator. Yeah. 1, -7. A little bit, not quite, not negative.
Wait, what? I thought we were doing 412.
-9 plus
Wait,
minus 8.
What are you doing?
Oh, you're doing A plus B plus A.
No.
Negative,
minus.
-9 minus 8.
This is it.
Now, if we type this into the calculator, we can go second matrix.
How do we get 7? Oh, we don't. That's wrong.
Over to edit. 2 by 2. So our first matrix is -3, 4, -9, -5. Once we type it in, we'll do second quit. To type the second matrix in, we go second matrix, over to edit, and down to B. It is also a 2 by 2. -4, 12, 8, -7. Y'all remember how to type these in?
I got that. Oh yeah, second quit, right?
Second quit.
And then after 1, 5.
So second quit, second matrix, we go again, all the way over to edit. But instead of doing the first one, we go to the second one, we go to B and hit enter. So quit, second matrix, over to edit, down 1, enter. Do it again. So after you get the one typed in, second quit, second mode.
So after you put both of those sets.
So after that, so we said the first matrix was A, yes? So second matrix, the first list name, we can hit enter. First list tells us to recall. Minus second matrix B. Got it typed in? Both of them do second quit. Second mode. Second matrix. So enter to get A minus second matrix B. Enter. Questions on this here? So with some of the addition subtraction, it is almost a little bit easier to just do it by hand. Do it in the calculator or by hand. Questions on addition or subtraction? Scale multiplication, 5R. Whenever we do scale multiplication, what we're doing is multiplying every element in the matrix C by that amount. So here we're multiplying them all by 5. So we say 5 times 12, 5 times 8, 5 times 6, 5 times -16, 5 times 4, 5 times 19. And then we can calculate each one of these here. 5 times -12 is -60. 5 times 8 is 40. 5 times 6 is 30. 5 times -16 is -80. 5 times 4 is 20. And 5 times 19 is 95. Questions on this here? Questions on this scalar multiplication so far? Now, if we want to do this in the calculator, we can look at the next one. So the first thing we would do is second matrix edit. Second matrix over to edit. I'm just going to hit enter. I'm going to plug it into matrix A. Now our matrix this time is a 2 by 4. 8, 0, 3, -2, -1, -4, -2. Once you get it all typed in, second, quit. Once you get it all typed in, second, quit. Now what we're wanting to do is what? -4 times the matrix that we have, yes? So the first thing we would type in is -4. Second matrix. And then select which matrix that we have. And hit enter. Yep. -32, 0, -12, 8, 4, 16, 8, -36. That's it. Questions on this here? Now we can also do these operations, addition, subtraction, with scalar multiplication. So we can say -4b minus 3a. So we can multiply matrix B by -4, multiply matrix A by -3, and then add the two together. And it would get us our answer. We can also, in the calculator, go second matrix. Over to edit for A. -9, 12, 2, -6. Up. 2 by 2. -9, 12, 2, -6. Second quit, second matrix. B. It's also 2 by 2. -4, -8, 2, -3. Questions on this here? Yeah, you're good. Once you get them both typed in, we're going to say second, quit. So we want to find -4b minus 3a, yes? So we'd say -4, second matrix B, minus 3, second matrix A. Question? So -4, second matrix B, minus 3, second matrix A. Yeah, we just have to type the whole thing in. So I would do it as this here. Now, luckily for us, most of these have been defining them as A and B, so we can just use that and go straight for name them A, B, C, D as they list. But if they give them something other than A and B, I would denote them on the sheet, which one's A, which one's B. That way, when you start plugging them in, you know which one is which. Questions on this here? Well, everything except for elements so far has not been new. Because we've gone over dimensions, we've gone over addition, subtraction, we've gone over scalar multiplication, and we've gone over using scalar multiplication with addition and subtraction. What is new is matrix multiplication. We have not multiplied two matrices before. But for us to be able to multiply two matrices, the columns of the first has to match the rows of the second. The columns of the first matrix that we're multiplying has to match the rows of the second. And if they do, then we can multiply them, and the new dimensions is the rows of the first by the columns of the second. So if we look at this first one here, A, 3 by 4 is being multiplied by B, 4 by 2. Columns of the first, does it match the rows of the second?
Yeah.
So yes, we can multiply these together. And A times B's new dimensions would be rows of the first by columns of the second. So it'd be 3 by 2. That's it. How about B? Columns of the first does not match the rows of the second, so not possible. 1A, columns of the first, rows of the second. Yes, it is possible. And our A times B, new dimensions would be 4 by 2. Last one.
Not possible.
Not possible. Because our columns of the first is 2, the rows of the second is 3. They do not match. Questions on any of this here? Now this is the walkthrough explanation of multiplying two matrices. I think sometimes it's easier to see it than it is to try to read it. So when we multiply two matrices together, what we're going to do is something I call over down. So what we're going to do is multiply the first row by first column. So we do 6 times -5 and add to it. So the next number in our first row is -3. Next number in the first column is 3. So we have -3 times 3. If we had another column, we would multiply it, another number in the first row, by the next number in the first column. So we keep going over down. Questions on this here? Well, that gets the first number in our new matrix. Now we do it again. We go over and down. So we'd say 6 times -4 plus -3 times 3. Since we don't have any more columns in the second matrix, we are finished with the first row. Now we repeat it again with the, so we go over down. So we'd say -10 times -5 plus times 3, because we go over down. So,
So like -10 and then -5, right?
yep, so first, -2 is 3.
You get it?
No. I plugged it in, but I don't know if that's.
So -5, so this is all, so 6, -3, 5, 3. 6 with the -5, -3 with the, So then the second spot, so -10 with the -5, -2 with the 3. So wait, because the calculator gave you the answer. This is not the final answer. Because we can't leave it as 6 times -5 plus -3 times 3. Because that's all numbers that can be simplified. Now, we do this one more time. We're going to go over and down. So -10 times -4 plus -2 times 3. Now, if we look at these here, we can simplify some things. 6 times -5 is -30. -3 times 3 is 9. 6 times -4 is -24. -3 times 3 is -9. The bottom row, -10 times -5 is 50. -2 times 3 is -6. -10 times -4 is 40. -2 times 3 is -6. Lastly, -30 minus 9 is -39. -24 minus 9 is -33. 50 minus 6 is 44, and 40 minus 6 is. Yeah. Over, down, over, down. Now we can type this into the calculator, just like we've been doing these. Second matrix, over to edit. There's a 2 by 2. 5, 9, negative 3, negative 2. Sorry, I was looking at the next one. Let me refix that. Second matrix, edit 2 by 2. 6, negative 3, negative 10, negative 2. There we go. Second, quit. Second matrix. Matrix B. 2 by 2. Negative 5, negative 4, 3, 3. So we said this time A was our U, or sorry, A was our X, B was our Y. And we don't have to put the multiplication between them, just having it A, matrix B, the calculator understands its multiplication, so it'll go on and multiply them together. So we do know multiplication, any two things multiplied in any order give us the same thing, yes? And this gives us the same thing also, yes? Matrices, multiplication with matrices is not closed under multiplication. We can't say A times B is the same as B times A. We do get two different things. So questions on multiplication?